Today we're going to work a little bit more with special cases of equations, and we're going to start to try to figure out how can we look at a simplified equation and know what kind of solution it's going to have. That's a skill that if you can recognize it early, I think you'll be less confused as you find some of those funky solutions, like the times where we have infinitely many solutions or no solutions. So this does rely on your equation being simplified. So when we say simplified, we mean no parentheses, we mean all terms are combined. But when they are simplified like that, we can actually just look at the equation and know what kind of solution it's going to have. So if you are following along on paper, I don't necessarily think you need to write down this top part. I'm going to talk you through it, but I would definitely write down the bottom examples. When we look at these equations, we're going to focus on the terms with variables. So in that first equation, it says 3x minus 5 equals 7x plus 3. So I'm going to focus on just my variables, 3x and 7x. When we have variable terms that are different, so 3x and 7x are different, those are going to be our one solution kind of problems. So you'll actually be able to get an answer like an x equals a number if the variables are different when you simplify. On the other hand, sometimes the variable terms are the same, and that's what creates either infinite solutions or no solutions. So for infinite solutions, we've got this example, 2 plus 4x equals 4x plus 2. And again, I'm going to focus just on the variable terms. I've got a positive 4x on both sides. So the variable terms are the same. 4x and 4x are exactly the same. And everything else is equal as well. I have 2 and 2. If both sides are equal, you're going to get an infinitely many solutions or infinite solutions. Sometimes we shorten that. Now, the no solution is going to happen. If we look, we had 8x plus 9 equals 8x minus 5. So I've got 8x on both sides. Here again, my variable terms are the same. But when I look at everything else, I see a 9 and a minus 5. So those sides are not equal. And that's when we get that no solution kind of scenario. So let's jump right in with an example. I'm going to give you just a second to copy down example 1. It says 2 parentheses 4x plus 5 equals 5 parentheses 2x plus 4. Our very first step is going to be to simplify. And when we say simplify, we mean get rid of parentheses, we mean combine like terms, neaten it up so that both sides have just a variable and a constant or a number, and the other side also has a variable and a constant. So in this particular example, I need to neaten up first by distributing. So I know when I distribute, I'm going to take what's on the outside of the parentheses and it's going to get multiplied to everything inside the parentheses. So on that left side, I have 2 times 4x, which is 8x, and 2 times positive 5 is positive 10, so plus 10. Then I have, on the right side, 5 times 2x is 10x, and 5 times 4 is 20. So now I'm going to pause right there. When we want to talk about a simplified equation, this is pretty simplified. We have just variables and constants on both sides. So we're going to look here at the variable terms. So I have an 8x and a 10x. So the variable terms here are different. Those are different variable terms. The coefficient is different, which means that this equation can be solved for an answer like x equals a number. So we're going to keep going and we're going to solve this. So I typically like, when I have variables on both sides, to move my variables to the left. You can certainly have some other first steps. That's just what I like to do first. So I'm going to subtract 10x so I can move it to the other side. And if I do it on one side, I have to do it on the other. 8x minus 10x is negative 2x plus 10 equals 20. And now we've got a two-step equation. So we can subtract 10 on both sides. And that gives us negative 2x equals 10. And then final step, divide by negative 2 on both sides. And that will give me x equals negative 5. So that answer, what that means is that the equation has one solution. The single only solution that will work is x equals -5. So we can write that, if we want to put that into words to describe what's happening, we can say that that solution means that -5 is the only value for x that will make the equation true. So this is what happens most commonly for our problems. We solve and we get an answer, a numerical answer, and that's our one answer. But there are those special cases where sometimes any number will work or sometimes no number will work. And that's what we'll look at in these next two problems. All right, so let me give you a second to write down example 2. We've got 2 parentheses 5x plus 4 minus 11 equals 4x plus 3 parentheses 2x minus 1. So again, my very first step is going to be to simplify on both sides. Whatever I can simplify and clean up, I want to do that first. So I'm going to draw that line down the equal sign, keep my work organized. And I notice here I've got parentheses that need to be dealt with. And I'm going to start there. So when I distribute that 2 on the left side, 2 times 5x is 10x. 2 times 4 is 8. Minus 11, that 11 doesn't go anywhere. And then 4x plus 3 times 2x is 6x. And 3 times -1 is -3. And now I notice that I have some like terms. So I'm still not as cleaned up as I'd like to be. On the left side, I notice I have an 8 and a -11 that could be combined. On the right side, I've got a 4x and a 6x. So when we combine on that left side, I've got 10x, positive 8 minus 11 is -3. 4x plus 6x on the right makes 10x. And I still have that -3. And now, just like we were discussing up at the very top of this page of notes, I focus on my variable terms. Everything's cleaned up, and I have 10x and 10x. So the variable terms are the same. And other than that, there's a -3 on both sides, so both sides are equal. And so what that tells me, without even going any further, if I can recognize it right here and say, okay, well then this will be an infinite solutions where any number will work, you can actually stop. But a lot of times we forget and we keep going. So I'm going to keep going one more step and show you what would happen. I told you in the last example, I like to move any x's on the right to the left, so I would subtract 10x on both sides. But when I subtract 10x on both sides, I get -3 equals -3. And now that's something that makes sense. It's kind of strange looking, but -3 is equal to -3. That is true. So we don't say that the answer is -3 here. When we get a statement like -3 equals -3, or when we notice that the equation is exactly the same on the left or the right, we call this infinitely many solutions. And sometimes you'll hear us shorten that to infinite solutions. So we would say this equation has infinitely many solutions. And what that means is that any value that we substitute in for x will make the equation true. So any value for x will make the equation true. And so again, we would say in our answer, we would actually say that our answer is this infinitely many solutions. So if I was going to box my answer off, I would box that statement off. All right, final example. Give you a second to write it down. It says -4x plus 3 parentheses 5x plus 6 equals 7, parentheses, 2x plus 1, and parentheses minus 3x. So again, we're going to have to simplify on both sides, which for this one is going to involve some distributing again. So I'm going to multiply that 3 on the left to everything in parentheses and the 7 on the right, which means when I distribute that, on the left side, I've got negative 4x, 3 times 5 is 15x, and 3 times 6 is 18. 7 times 2x is 14x. 7 times 1 is 7. Still have that minus 3x. And now, still not as neat as I would like, so I'm going to continue to clean up and combine like terms where I can. So on the left side, I have 2 terms that both have an x. And on the right side, I also have 2 terms that both have an x. So I'm allowed to combine those since they're on the same side of the equal sign. So negative 4x plus 15x is 11x. 14x minus 3x is also 11x. So now that it's nice and neat with just variables and constants, I'm going to look at my variable terms. This time again, the variable terms are the same. But when I look at everything else, I have an 18 and a 7. So both sides are not equal in this problem. And that means this is going to be a no solution. But again, sometimes we forget that and we keep going. So let's look at what happens. I'm going to subtract 11x on both sides to try to combine those, which will leave me with 18 equals 7. And now that makes no sense, right? 18 and 7 are not equal. That is a false statement, and that's what happens when we get a no solution. Nothing is going to make that true. So we would say this equation has no solution. So that would be my actual answer to this problem, which means there is no value for x that will make the equation true.